It's easy to forget when you're somewhere like this, but the world has suffered from a series of global catastrophes, disasters that have wiped out 99% of all the species that have ever lived. But the forces that wiped out many of our ancestors are still at work today. All we have to protect us is a wisp of atmosphere, and all we have to stand on is a thin crust. Mankind could be the next dominant species to face extinction. This is the story of how vulnerable we really are. Our planet has been shaped by an endless cycle of destruction and renewal. The result, 99% of all the species that have ever lived are now extinct. But we tend to forget that the very forces that created all this havoc are just as powerful as ever. We've been lucky so far. We humans haven't been confronted by a truly global crisis yet. But history reveals that we're much more at risk than we might think. Another big one could be just around the corner. To understand the sheer scale of Earth's 4.5 billion year history, imagine it as the 24 hours on a clock. Earth formed at midnight. Just 9 minutes later, disaster struck. Our planet collided with another. But Earth survived and life evolved. Then at 8:30 p.m, another disaster. The entire planet froze over. 10:40 p.m, massive volcanic eruptions poisoned the planet. Life was nearly wiped out. And at 11:38 p.m, a giant asteroid killed off the dinosaurs, leading to the rise of the mammals. It was only in the closing minutes of the day that our planet became a place we'd recognize. Finally, at under a minute to midnight, a tough new species marched towards world domination. They spread rapidly, adapting to every challenge. This new species was Homo sapiens, us. 85,000 years ago, we were just heading out of Africa. Today, we're everywhere. This is the story of what happened since humans walked the planet, and it shows just how vulnerable we really are. Again and again, our ancestors confronted catastrophes. All of them were different, but any one of them could have stopped human civilization in its tracks. The first disaster struck India 74,000 years ago. Today, evidence for this event can be found in the most unlikely place, inside the cells of our bodies. The story of the human race is written in our genes. Our genes control not only what we look like, they also record evidence of past disasters. For geneticist Stephen Oppenheimer, it's a crucial clue.
As you move away from Africa, the overall genetic diversity reduces in different populations until you get to the Native American populations, which have the least diversity of all. But there is one place where there's an anomaly. That's India.
In India, genetic diversity is much, much lower than it should be. Oppenheimer believes some kind of disaster must have struck India's early settlers. Something so severe that their descendants' genetic diversity is still affected today. Whatever it was, this ancient disaster came close to wiping out the whole subcontinent.
It's difficult to estimate the size of reduction, but it might have been down to about 600 people in the whole of India.
Whatever struck India, it was absolutely devastating. Something powerful enough to wipe out most of the population.
There is, of course, a very obvious catastrophe, which is clearly dated in the right time zone, and that is Toba.
Toba is an Indonesian supervolcano. Its last eruption is described by volcanologists as mega-colossal. That's as big as it gets. The date? 74,000 years ago, the estimated time of the Indian disaster. Was it a coincidence? Or was it the catastrophe that nearly killed off India's people? On our clock of the Earth's history, it's less than 2 seconds to midnight. 74,000 years ago, the Indonesian supervolcano Toba erupted. Our ancient ancestors were faced with a terrifying threat. Volcanoes are one of the most powerful forces on the planet. They can devastate whole regions and even affect global climate. This is Mount Augustine off the coast of Alaska. It's not a supervolcano, but it does illustrate the raw power of even a fairly small eruption. It last blew in 2006. Volcanologist John Power is monitoring how it's changed since then.
We're on our way to Augustine Volcano. It's one of the most active volcanoes in the Cook Inlet region.
During the last eruption here, Augustine blasted out 65 million cubic meters of rock. So much debris that the summit grew by around 70 meters. The eruption here was big, though it was nothing compared to the power that could be unleashed by a supervolcano. But studying smaller eruptions like Augustine gives scientists an insight into the incredible power of the Toba eruption 74,000 years ago.
We're sitting on Augustine Island, which is the home of Augustine Volcano, which you see behind us. We are at the very northern end of what's called the Ring of Fire.
The Ring of Fire is the chain of volcanoes that surrounds the Pacific Ocean. It's the world's most volcanically active region. Mount Toba lies in Indonesia, at its western edge.
Here at many of these volcanoes in the Ring of Fire, you have very explosive types of eruptions, very powerful things that throw ash and so on out in very high elevation in the atmosphere. There's no place where things are quite as active as Indonesia.
Indonesian volcanoes have produced some of the most violent explosions on the planet. The Toba eruption was the biggest on Earth for 2 million years.
The forces are quite extreme during one of these large explosive volcanic eruptions. You have magma that's coming up underneath the volcano. Inside that magma, you have a lot of gas and so on that's absorbed inside the magma itself. And it's really this gas pressure that is driving a lot of the eruption.
An average volcano might contain enough gas and magma for the eruption to last for hours. Toba must have erupted for days. But while such eruptions are rare, disturbingly, the volcanoes that cause them aren't. 47 supervolcano sites have been discovered worldwide. Many are no longer active, but a few are, and they pose a real threat to human society. The most famous one of all lies in the United States. Yellowstone. This bizarre landscape attracts over 3 million visitors every year. They come here to witness the raw power of the park's famous geysers. Yellowstone has the largest collection of such hydrothermal features anywhere on Earth. 2/3 of the world's geysers are in this one park. That takes a lot of heat. In fact, it takes a supervolcano like Toba, only hidden below ground. The last super eruption here was 640,000 years ago, long before humans ruled the planet. But even after all this time, you can still see evidence of this ancient blast. And the volcano itself remains active. One day, it will erupt again. For geophysicists like Bob Smith, Yellowstone is a vital research centre. For decades, Smith has been studying the Yellowstone caldera, the giant volcanic crater in the centre of the park. His work reveals just how devastating the eruption of Toba would have been.
We're standing here on the east side of Yellowstone Lake, and this sharp hill in front of us is actually the caldera boundary. And the caldera essentially occupies this entire expanse of the landscape that we can see. This whole system exploded out during the last giant eruption. This is a giant caldera, probably one of the biggest in the world that's known, and this is active.
The sheer size of the Yellowstone system makes it a key location for the study of the ancient Toba supereruption.
The Yellowstone caldera compares to Toba roughly in the same dimensions of about 60 kilometers by 40 kilometers. Toba has a large lake occupying the caldera as Yellowstone Lake, so it's very similar in size.
These hills and rocks were sculpted by immense forces. The whole landscape has been shaped by the giant volcanic furnace below. The magma chamber. This is the zone where molten rock gathers under immense pressure deep below the caldera. The bigger the magma chamber, the deadlier the eruption. Smith's work here at Yellowstone shows Toba's magma chamber would have been huge. This is his laboratory.
We're here at a site on the east side of the caldera where we have a seismograph which records ground motions that relate to the vibrations of the Earth when we have the passage of seismic waves. So we record 2,000 to 3,000 earthquakes a year here.
By mapping his seismic data, Bob can estimate the size of the magma chamber. His results are stunning. This simulation shows the whole United States. Yellowstone Park lies near the middle, its boundary marked in green. Yellowstone Lake is marked in blue, the edge of the volcanic caldera in red. Bob's seismic data, plotted below the surface, shows the enormous size of the magma system beneath the caldera. Yellowstone's magma chamber is an astounding 16 miles wide, 31 miles long, and 5 miles deep. That's 500 times the size of the City of London. That's an awful lot of magma. Scientists now believe that Toba's magma chamber was roughly the same size, and the scary thing is that if that amount of magma erupted again, it would be absolutely devastating, and the aftermath would affect us all. But the problem wouldn't be the red-hot magma. The real killer would be volcanic ash.
When the magma actually finally makes it to the surface, the gas pressure will drive that magma, fracture it, pulverize it into what a volcanologist would call ash. This is pulverized rock and minerals all ground up together by the explosive forces. And that stuff can be thrown out into the atmosphere to great altitude.
It's thought that Toba's eruption column reached the very edge of space. This footage from the space shuttle of the Russian volcano Mount Klyuchevskoy erupting shows how high ash can be blasted into the atmosphere. But at Toba 74,000 years ago, this was just the beginning.
As all those gases and pulverized rock rise up, it's hot, very hot, about 1100 degrees centigrade when it comes out. It'll rise up first buoyantly under its own heat. And as it begins to cool, it will become too heavy for the atmosphere to support, and it will rush back down the sides of the volcano. This creates a very hazardous phenomenon that we refer to as a pyroclastic flow.
These superheated ash flows can be immense. At Toba, they buried the landscape up to 200 meters deep. Any humans nearby would have been annihilated. But even those outside this initial danger zone weren't safe. Toba's volcanic ash travelled for thousands of miles.
There was a massive release of ash, and that ash went northwest in the Indian Ocean and covered India.
12.5 million square miles of the Earth's surface were covered in ash. Anyone living in the fallout faced starvation.
The Toba ash fall would have affected the vegetation in a big way in India. And the immediate effect of that would be that the game that humans relied on didn't have any vegetation to eat. And then, of course, the human predators, being at the top of the chain, suffer much more.
The ash was deadly. But volcanoes have an even deadlier weapon in their arsenal. The gas, sulfur dioxide. Toba may have released as much as 3 billion tons of it. Volcanologist Bill Maguire has studied how sulfur dioxide can affect the entire planet.
When sulfur dioxide gets into the atmosphere, which it does with a big volcanic eruption, it combines with water vapor and it forms a fine mist of sulfuric acid. Billions of these tiny little sulfuric acid droplets in the atmosphere, they act like tiny mirrors, so they reflect solar radiation back into space.
The result? The planet cools down and enters a volcanic winter.
There's some debate about how much of a temperature fall Toba actually led to, but in the extreme case, it could have reduced global temperatures by 5 to 6 degrees centigrade for a period of several years. And that would have literally caused most of the world's vegetation to die off.
The effects of another super eruption today hardly bear thinking about. Starvation would wipe out huge numbers of people.
If we saw a super eruption today that resulted in that same temperature drop, then we would experience global harvest failure. Now, I can't see any way that cannot result in billions of deaths.
If another of Earth's active supervolcanoes does what Toba did 74,000 years ago, it would be a disaster for us all.
Well, super eruptions, on average, seem to occur about every 50,000 years or so. But of course, the Earth doesn't operate to a timetable. So when the next one's going to occur, we really haven't a clue.
The Toba supervolcano affected vast numbers of people in India. But 70,000 years ago, the survivors faced a new threat, this time one that would affect the whole planet. A global big freeze. Half a second to midnight on our clock of world history, 21,000 years ago. The planet was in the middle of an ice age. Throughout history, ice sheets have helped form the story of the Earth. The biggest one was 650 million years ago, when the planet was virtually engulfed in ice, and we had a lucky escape when volcanoes broke through it and warmed the planet again. In the millions of years since that big one, ice sheets have frequently returned, just as they will again one day in the future. "21,000 years ago, Earth was gripped by the most recent of these big freezes. Glaciers steadily advanced across the northern hemisphere. For our ancestors, there was no escape. Glaciations occur on a regular cycle caused by variations in Earth's movement through space. Sometimes Earth moves further from the Sun, so the planet cools and the ice caps expand. The glaciers of the last ice age reached their furthest point south 21,000 years ago, a period known as the last glacial maximum.
The last glacial maximum in Europe is about as bad as it can get. And that meant an ice cap 3 miles thick, which covered half of Britain. And around that ice cap to the south was a polar desert, which didn't have ice on it, but also didn't have much vegetation or people.
For our ancestors, it was migrate or perish. They didn't return until the big thaw began around 7,000 years later. And when the glaciers retreated, it changed everything. Released from the grip of the ice, civilization was finally free to begin. Agriculture, cities, the Industrial Revolution, banks, you get the picture. The end of the Ice Age made it all possible. But the irony is, our civilization is now so complex that we'd be helpless if the glaciers advanced again. And if there's one thing that's certain, it's that one day the ice will return. Even now, Earth's orbit is taking it further from the Sun. Another glacial advance is due any time. The return of the ice would be a brutal shock. In 1998, we got a glimpse of just how brutal. An ice storm hit the city of Montreal. Freak weather conditions created a relentless build-up of ice. 1,000 electricity pylons collapsed under its weight. The power supply failed. Millions of inhabitants were left without heating. And the temperature continued to fall. The Montreal ice storm exposed our society's Achilles heel, our reliance on near-perfect conditions. If the glaciers were to advance once again, there's not much we could do to protect ourselves.
Inevitably, a new ice age, if it occurred very rapidly, would lead to complete social and economic breakdown. People would move towards the equator from northern countries like the United States, the UK, Europe. That would be a recipe for war and conflict without any doubt.
The civilization that makes our lives so comfortable also makes us vulnerable. But 13,000 years ago, that's less than a second to midnight on our clock, our Stone Age ancestors were luckier. They had simply migrated south and survived off the land. Humans had now made it through a super eruption and an ice age. The risk of lightning striking a third time seemed remote. Sadly, it wasn't. The planet had done its worst, but there was still space to be reckoned with. Asteroids have struck Earth throughout history. In the ancient past, they even caused mass extinctions. And scientists are now beginning to wonder if humans could also have been affected by a cosmic catastrophe. This is Ohio in the USA.
This is the site of a major catastrophe. Something happened which had a profound effect on the life of the times.
Archaeologist Ken Tankersley believes that at the end of the last ice age, 13,000 years ago, this region suffered a catastrophe that originated in space. These days, most of Ohio is farmland, but one small area of marsh remains. It's just as it was 13,000 years ago. Except for these. Back then, the area was home to an impressive collection of beasts.
There were mega mammals roaming this area, which included mammoths and mastodons.
These mega-mammals were food for the continent's top predators, humans.
The people who lived here, we refer to as Clovis. They were Stone Age hunter-gatherers. They were hunting wild game and gathering wild plant foods and living in extended families. These people had successfully adapted to the landscape for thousands of years. And then came a catastrophe. The mega mammals went extinct. Their livelihood was gone forever.
Clues to the cause of this catastrophe lie 10 meters below ground. This is Sheridan Cave. It's a natural time capsule. Its secrets might solve the mystery of the missing mega-mammals. Tankersley's work in the cave has unearthed a treasure trove of archaeological remains, all of them dating to the time of the disaster. It's a long descent down to the bottom of the cave and a journey back in time. Recent excavation has revealed a dull red layer which marks the exact moment that the mega-mammals vanished from the fossil record. It's known as the Clovis layer.
We're looking at the Clovis layer. It's a very distinct layer here in the cave. Beneath it, we have mega-mammal remains. Above the layer, there are no more mega-mammals. This literally represents the extinction event.
And you can find the same thing at more than 20 other sites across America. The sediment layer marks the exact moment the mega-mammals disappeared.
One of the things that intrigues me about this time period and about this site is we have no clear-cut answer as to what caused the extinction of these mega-mammals. Overhunting, people killing these animals just does not fit. And when we look at all the other ice ages which came to an end, these mega-mammals did not go extinct. So why now and why here? This is one of the most intriguing questions that I've ever faced.
Excavation here continues. Even after a decade, they're still digging up bones.
Even though this bone looks fresh, it is actually 13,000 years old. It dates to the extinction event.
And it suggests a violent death.
What's really exciting about this particular specimen is there's clear evidence of burning, literally a blackened color.
This is the tibia of a now extinct pig-like creature the size of a modern-day wild boar.
In order to burn the flesh off of an animal the size of a European wild boar, we're talking about temperatures between 300 and 600 degrees centigrade. This is not an animal that was subjected to a cooking fire.
This animal was incinerated, and so was the entire landscape.
We're talking about a massive fire, almost an explosion of heat and pressure. The question is why?
It's nearly midnight on our clock of the Earth's history. 13,000 years ago, a disaster struck America. The mega-mammals were wiped out, and the people who hunted them lost their main food source. The cause of this disaster has long been a mystery. But deep in these Ohio caves, archaeologist Ken Tankersley has discovered something which might provide the answer.
This is a meter which measures the magnetism, the amount of iron. The higher the iron content, the greater the magnetic susceptibility of this layer. First, put the probe in this gray area below the Clovis layer is a perfect spot. And we check the magnetism. We see that it has a magnetism of 8. Now what we're going to do is compare that with the layer above it. The reading is 50 times the iron content. In other words, the magnetic susceptibility is 50 times higher than the area that's gray.
A basic experiment reveals just how rich in iron the Clovis layer really is. A magnet dragged across the surface is left covered with iron particles. It's a simple test with an astonishing implication. It suggests this region was hit by an asteroid.
This suggests that there was some type of catastrophic explosion, one which not only deposited meteoric iron, but one that was also intense in temperature and pressure.
An asteroid strike meant North America's mega mammals were doomed. They couldn't adapt to the challenging conditions that followed the disaster. But humans could, and the survivors flourished. It's a controversial theory. But it wouldn't be the first time that death had come from space. Scientists believe that 65 million years ago, an asteroid wiped out the dinosaurs, leaving behind a giant crater. The trouble is, for the Clovis event, no crater exists. But one man has a theory which might explain why there isn't one. Planetary geologist Peter Schultz has come to this NASA research center in California to conduct an experiment with this giant gun. It's so powerful, it can fire projectiles at over 15 times the speed of sound.
This is one of the big guns, the fastest gun in the West. This is where we have a chance to actually fire small bullets, small BBs at very high speed.
Schultz and his team will be firing the gun to find out if an object from space could strike the Earth without leaving a crater. Schultz is testing a theory that glaciers could have protected the Earth's surface. During the Clovis era, much of North America was covered by a vast ice sheet up to a mile thick, a remnant of the last big freeze. Schultz hopes a scale experiment will show whether glaciers could have prevented an asteroid from leaving a crater in the underlying rock.
The question we really want to address is, will the ice actually protect the Earth below? This is our projectile. It's just 1/8 of an inch, about 3 millimeters or so. And we're going to be firing this at a speed of about 5 kilometers per second.
The team prepares the gun for firing. A number of ultra-high-speed cameras will film the impact for later analysis. Inside the impact chamber, Schultz prepares the target. The red sand represents the surface of the Earth.
This will add some color, at least to the surface layer. And this way we can tell whether or not we punctured through the surface or not. So we have loose sand underneath, and we have the red layer on top. We're going to do one experiment when we slam just into this target like we have it, and the other one where we put a thin layer of ice. And the idea behind that is whether or not this ice will act as a flak jacket. Now we just have to go hit it. Let's see what happens.
The gun is raised into the firing position. And the countdown begins. The team waits in a sealed bunker, well away from the gun itself.
Wow. Now that did some damage. So this is big. So we gotta slow this up now and take a look at the slow-mo. Kapow. So this is now the entire impact with the streak through and the impact. Stuff that's going downrange at extremely high speed. That clears away and we have the crater forming. And now the crater just grows and grows and grows and grows and keeps growing.
High-speed footage shows the devastating impact on the exposed sand surface. But the best evidence is inside the impact chamber itself.
Sweet. Oh, that's nice. Now that did some damage. So this impact was a good size impact. This was hypervelocity. It slammed in. It excavated stuff from below. If we scaled this up to a big crater on the Earth, it would last for millions of years. So the next stage is to repair this target, make it look like it was before we had the impact, but this time, let's put down a slab of ice, kind of resembling what might have been on the Earth when there were glaciers. Now we have the ice on top of the target. And what we want to know is whether or not this ice actually buffers or protects the underlying target from the impact. Sweet. And we see that the vapor expands, and we're seeing a little bit of ice come out. And the ice clears away, and the real question, I'm really anxious to see, is whether or not we really produced a crater. Right now, I don't see a crater. Let's see what we did. Oh man. Oh, that's remarkable. The ice was here, and it really protected the target underneath, and that's just simply loose sand. So with time, these pieces disappear, they melt away, and all we have is a tiny little crater. And if this were the Earth, it could be easily eroded away. And so when that ice disappears, there's just nothing left. It's the perfect crime.
It's only a scale model, but it shows an ice sheet could have masked the evidence of a powerful impact 13,000 years ago. Maybe the mega mammals were wiped out by a cosmic catastrophe. One day, we may face a similar disaster. Advanced warning will be essential for our survival. Something astronomers in Arizona are working to provide. This is Mount Lemmon Station, part of the Steward Observatory. Here, asteroid hunter Ed Bishaw combs space for near-Earth objects, NEOs. There are millions out there right now. And not surprisingly, governments worldwide consider them a real threat.
Well, the Earth traveling around the sun is much like a race car traveling around a circular track. And a NEO collision might be very much like a car coming suddenly out of the pits in front of the race cars, representing an immediate impact threat. And of course, the consequences of a collision would be devastating.
Each night, Bishaw's team photograph the skies searching for anything that moves.
Hey, Andrea, have a look at this.
It's moving fast.
Yeah, it's quite bright. It's 19th magnitude, and it's got a digest score of 100.
Let's check if it is known.
Yeah. There's no ID on this. This object is new.
The team have found an NEO. It's painstaking but vital work.
We take 4 images spaced over about 45 minutes, about 10 minutes apart. So here you see 4 images being shown in sequence. Our computers register the images so that the stars don't move, but any object which is moving on the sky is revealed like you see the object here.
Fortunately, this near-Earth object is probably harmless.
This object is, in fact, what's called a virtual impactor, which means that there is a very small probability that there might be an impact in the future.
It's big, but luckily it poses little risk. But for every large object in space, there are many thousands of smaller ones, and they can pose a real threat.
The asteroids are like gravel. If you pick up a handful of gravel, you're going to find that there's a few large objects in there, but there's a whole lot more smaller objects. And it may be these smaller objects that, in fact, might be on a collision course with the Earth.
And you don't have to look far to see what even a small asteroid can do. This is Meteor Crater in Arizona. 50,000 years ago, this impact devastated hundreds of square miles. And the asteroid that did it was just 50 meters across. But if you think 50 meters is small, check this out. This is the aftermath of a large explosion in the remote Tunguska region of Siberia in 1908. Fallen trees fanned out from a central blast point for hundreds of miles. There could be only one cause, an asteroid exploding with the power of a nuclear bomb. And its estimated size? Just 10 meters across.
Tunguska is the only hard evidence we have of a recent impact on planet Earth. So we can look at that and say, that's pretty scary. If that was a city underneath there, it would be completely obliterated. And it's quite interesting that if you look at the area that was destroyed and superimpose it on London, for example, virtually the entire area of Greater London would be wiped out.
This catastrophe shows just how vulnerable we are. Tunguska-sized projectiles strike Earth roughly once a century. The last one was 100 years ago. Another deadly asteroid could turn up any day. The history of our planet is an endless cycle of extinction and rebirth. So it should come as no surprise that we humans are as vulnerable as our predecessors who are long extinct. We've suffered disasters, but not on a global scale. If we had, we wouldn't be here at all. It's not that we've been lucky, it's just that we haven't been unlucky yet.